So in this problem, we have the function f of xy equal to x to the fourth minus 4xy plus y to the fourth. And we would like to find and classify its critical points. What we mean by that is we're going to use the second derivative test. Let's recall that if we have a critical point, by critical point, we mean that the gradient is equal to 0, meaning that both partial derivatives are going to be equal to 0. We consider the determinant f that is made up of the second order partial derivative, so fxx at ab, and then you have fxy at ab. Technically, you're putting here fyx, but by Clairaut's theorem, this is the same as fxy at ab and fyy at ab. And unless this is 0, it's going to really tell you what's going on with this critical point. So if it's less than 0, then we have a saddle point. And if it's greater than 0, then there are two cases. F sub xx at AB is greater than 0, in which case we have a local minimum. And fxx at AB is less than 0, in which case we have a local maximum. Note that there is no way that D is greater than 0 and fxx at AB is 0. If that were the case, then you could simply get your determinant to be minus fxy of AB squared, which is a non-positive number. So, okay. So why don't we get started by finding the critical points of the given function? So f sub x is equal to 4x cubed minus 4y, and f sub y is equal to 4 or minus 4x plus 4y cubed. And we would like to set them both equal to 0, because by critical point, we mean a point at which both derivatives are equal to 0. And if we divide both equations by 4, we will come up with x cubed minus y is equal to 0, and minus x plus y cubed is equal to 0. So the first equation can give us y is equal to x cubed. And once we know that y is equal to x cubed, we can plug it into the second equation, and that will give us minus x plus x cubed is equal to 0. So altogether, this gives us x to the 9th minus x is equal to 0. Let's solve this equation. We need to factorize it as much as we can. So this is x times x to the 8th minus 1 is equal to 0. Now x to the 8th can be written as x to the 4th minus 1 times x to the 4th plus 1, the identity of difference of squares. After all, x to the 8th is x to the 4th square. And this can be written as x squared minus 1 times x squared plus 1 times x to the 4th plus 1 equals 0. And finally, we will get x times x minus 1 times x plus 1 times x squared plus 1 times x to the 4th plus 1 is equal to 0. So now, this part is never 0. I mean, it's a non-negative number plus 1. This part is also never 0. So what are the possibilities? This could be 0, that could be 0, and that could be 0. So we can easily find that x is equal to either 0 or 1 or -1. And by remembering that y is equal to x cubed, that will give us the point 0, 0, because y is 0 cubed, or the point 1, 1, or the point -1, -1. So these are our 3 critical points. These are the 3 critical points, and for each one of them, we need to compute the discriminant. It's actually both a discriminant and determinant, but we call it a determinant that we have mentioned. So to that end, it's a good idea to find the second partial derivatives. So the second partial derivative with respect to x will be 12 x squared. With respect to y twice, it's going to be 12y squared. And with respect to x, and then with respect to y, is going to be -4. So let's start with 0, 0. For 0, 0, we will have that d is how much? Plug in 0, 0, you will get that this is 0, this is 0, this is -4, this is -4, compute this determinant, this is -16. So this tells you that 0, 0 is a saddle point. I also like to call these points Pringle points. This is something that I read once on a blog by Terence Tao. So in some sense, saddles and Pringles are the two easily identifiable surfaces that depict that that have points at which the gradient is 0, but there's no minimum nor maximum. Okay, let's go to 1, 1 now. At 1, 1, d is going to be what? 12 minus 4, minus 4, and 12. So this is 144 minus 16, also known as 128, which is greater than 0. So we do have a local extremum. And since f sub x at 1, 1 is equal to 12, which is greater than 0, this has to be a local minimum. Finally, at -1, -1, d is going to be again the same thing, 12 minus 4, minus 4, 12, which is 128. We already found that. And fxx at -1, -1 will also be 12, which is greater than 0. And again, this is a local minimum. So overall, we have 1 saddle point and 2 local minima. And that's it. Thanks for watching.